Okay, hi there everybody. I'm going to tell you a little story which is going to lead into a math lesson. There was once a little boy named Rupert. There he is right there with his striped shirt. And he had a forest. And it was a beautiful forest. He liked it so much he called it the magical forest. The magic forest. Okay, anyways. Rupert had a certain number of trees in his forest. He had a lot of trees in his forest. Okay, I'm not going to tell you how many there were. Okay, but this is what you're going to figure out. Okay, but he wanted more trees. Okay, because he liked his forest so much and he wanted it to keep growing. He wanted to plant more trees. So every day he said, "I'm going to plant a certain number of trees every day." Okay, and I'm going to make my forest grow and grow and grow. But if he's planting a specific number of trees, what does that tell you? Okay, it's a steady rate. His forest is going to be growing at a steady rate. So every day, keep that in mind. He's planting a certain number of trees. Okay, so let's go back to the picture here. Okay, so here's Rupert. He's planting his trees. That's part of the forest. And he called it the magic forest, as we said. Okay, so here are the questions I want to ask you. Okay. Well, here are the clues first. Okay, let's go over here to the clues. After 7 days, Rupert has 369 trees. Okay, and after 20 days, Rupert has 590 trees. Okay, so that's the only clues we're given here. We know that it's a steady rate, and we know that after 7 days, 369, after 20 days, 590. So here are the questions we want to answer about Rupert's magic forest. Okay, first question is, how many trees were in Rupert's magic forest to begin with? That means how many trees did he have before he decided to start planting more little trees? Okay? And the second question is, how many trees did Rupert plant each day? Okay. Oh, I wish I knew that. That would make these questions a lot easier here. And next one, how many trees will the forest have after 30 days? And then when will the forest have exactly 1,100 trees? Okay? So the good thing about this topic is that it's both an Algebra 2 topic and an Algebra 1 topic. Okay, so we are going to see this again and again, but it's a beautiful way to use a function, okay, to solve a real life problem. Okay, what type of function are we going to have if we have a steady rate of increase? And that is to say, if Rupert starts out here, if we have coordinate plane. If Rupert started out here with a certain number of trees, we don't know how many, but here are the days ticking by. Okay? After 1 day, he plants a certain number of trees. Tick, tick, tick. After another day, he plants another certain number, the same amount of trees. Tick, tick, tick. After another day, same amount of trees. Tick, tick, tick. So you see what's happening here. Because it's a steady rate, that little steady, those steady steps there, okay? If you connected the tops, what you're going to have is you're going to have a line, okay? So you might have guessed this already, and I hope you did, okay? It's going to be a linear function, okay? Linear coming from the word line, okay? It's going to produce a line if we graph the time, the days that Rupert's planting the trees, and the number of trees that he has in his forest. Okay, so let's just start from that point right there. We know we're going to have a linear function. And what is the slope-intercept form of a linear function? Do we know this? Where we have the slope given and the y-intercept. Okay, we should know this. Okay, the slope-intercept form is y equals mx plus b. Okay, I'm just going to check the camera and make sure it's aimed right. I wish I had someone here. Oh, that is perfect. Wow. Okay, yeah, well, there it is perfect now. Okay, so y equals mx plus b. Okay, now we take our clues here. Okay, we know that after 7 days there are 369 trees. Okay, so we can actually take that clue, input 7, okay? Our output of trees is 369, okay? So there's a relationship there. They make a pair, okay? Or in other words, we can make a coordinate from those two because they pair up. When the input is 7, the output is 369. And when we're talking about x's and y's, as we often do with the Cartesian coordinate plane, okay, our input is our x value. Okay? So this will be our x value. So when x is 7, y is 369, and we can just put those together as a coordinate, sorry. Whoa. What's going on? Okay. 7, 369. Okay? So that would be 1 point on the line of our function. Okay? And we have another clue, which is that after 20 days, so input 20, what's our output? If you were paying attention, it's 590. So when the input is 20, the output's 590, or when x is 20, y is 590, we can make another point on our graph. Another coordinate here. 20, 590. These are also called ordered pairs. They're called points, ordered pairs, coordinates. Okay? But the important thing to keep in mind is that this is our x and this is our y. Okay? How can we use those clues now to write a function, a formula in y equals mx plus b form, okay? And then use that formula to answer those questions. Okay? Well, if you don't mind, I'm gonna erase this. I hope you have a notebook handy and you're taking notes on this. Okay? So let's erase this now. We just need the coordinates there. Okay. Okay, so here we go. What's the first thing we need to know? Remember I told you before, I'd love to know the rate at which he's planting the trees. That's the one thing. If I just knew how many trees he was planting each day, then we can use that to pop it into our y equals mx plus b form, okay? Slope-intercept form of a function, okay? So here we go. Let's see. What is the slope formula? Do you remember the slope formula? If you don't know, you still could figure it out, okay? So what's the change in our y's? Because slope, as we know, it's the change in rise, okay? Or the change in y over the change in x. That's slope, okay? That would give us the slope, which is what we're looking for. And you remember where slope goes? Slope is the m part, okay, of this equation here, or this function. Slope is the m part, so here's the formula for finding it. It's the change in y over the change in x. In other words, we can take our first y and subtract it from the second y. Okay? So if our first y was 369 and our second y was 590, we can say 590 minus 369, okay? That'll give us our change in y, okay? Over our change in x, well, our second x was 20, our first x was 7, so we're left with 20 minus 7. So if we can just do this little calculation here, we should be good, okay? I'm going to pause 1 second here, hold on. No problem, anytime. Talk to you soon.
You will. Take
Okay,
care.
bye-bye. Okay, I'm back. Here we are. So if we can just do this little calculation here, okay? 590 minus 369. Does anyone know that? Well, guess what? Just to save time, I'm going to use my calculator, and I don't want to make any mistakes there on camera either. Okay? But I know you guys would understand. In fact, I understand if you make mistakes. So you guys should understand when I make mistakes, right? Okay, so 590 minus 369 equals 221. Okay, and what's 20 minus 7? Oh, that one we could do. That's 13. So our slope is going to be 221 over 13. Okay, so what's 221 divided by 13? We get a nice, neat number. Actually, that's one of my favorite numbers, 17. Cool. Okay, 17. All right, so that's our slope. There we go. So we just solved a big piece of this puzzle. Okay? Are you happy about that? You want to grab a snack? You want to pause? Okay, grab yourself a cupcake or whatever while I erase this, okay? You can just pause and I'm going to erase this. Ready? Here it goes. Okay? Okay, so we don't need this information anymore. We have the slope. That's our key. Okay? But now, we're going to take our equation here, y equals mx plus b, and since we know what the slope is, why don't we pop it in here? Okay? So, we now have y equals 17x plus b. Okay? Great. So in order to get y, this is what the function does. It gives us the formula. In order to find y, the output, the number of trees, total trees in the forest, we just have to take the x, the input, that's the number of days that Rupert is planting, right? Okay, by the way, we should have established that early on. What does x represent? What does y represent? Oh,